So now, let's talk about greenhouse gases. So greenhouse gases are specific gases in the Earth's atmosphere that can absorb and emit infrared radiation, a type of heat energy. When sunlight reaches the Earth, the planet's surface absorbs some of this energy and re-emits it as infrared radiation. The greenhouse gases such as carbon dioxide, methane, nitrous oxide, water vapor, and ozone trap some of this heat by absorbing the infrared radiation. After absorbing the heat, these gases re-emit in all directions, including back and forward, the Earth's surface. This process, known as greenhouse effect, helps to maintain the Earth's temperature at levels suitable for life. However, human activities like burning fossil fuels and deforestation have increased the concentration of these gases, trapping excessive heat and contributing to global warming and climate change. The British engineer, physicist, and chemist John Tyndall quoted, "As a dam built across a river causes a local deepening of the stream, so our atmosphere, thrown as a barrier across the terrestrial rays, produces a local heightening of the temperature of the Earth's surface." This compares the atmosphere to a dam across a river. Just like dam makes the water behind it deeper, the atmosphere traps heat from the Earth, making the surface warmer. The atmosphere acts as a barrier, holding in heat and raising the temperature near the ground, similar to how a dam changes the flow and depth of a river. In the middle of 19th century, John Tyndall made important observations about the greenhouse gases. He identified that the most prevalent greenhouse gas in the atmosphere at that time was water vapor. Water vapor plays a significant role in trapping heat in the Earth's atmosphere. Meanwhile, Tyndall noted that the amount of carbon dioxide was very small, and it was not yet considered as a major concern. However, Tyndall was concerned about what could happen to the Earth's atmosphere if industrialization expanded. Industrialization, the process of transforming a primarily agrarian economy into an industrial one, involves in large scale of use machinery for production. The operation of these machines requires electricity, which in Tyndall's time was primarily generated by burning fuels like coal. This burning of fossil fuels produces carbon dioxide as a byproduct, releasing it into the atmosphere. At that time, manufacturing plants were not as widespread, and industries were not producing significant amounts of carbon dioxide. Therefore, Tyndall did not see the emissions of carbon dioxide as an immediate problem. However, he recognized that if industrialization were to spread and grow, the increase of carbon dioxide emissions could have serious long-term effects on the Earth's climate, potentially leading into global warming and changes in weather patterns. This foresight foreshadowed the concern we face today regarding the environmental impacts of industrialization and greenhouse gas emissions. By the mid-20th century, industrialization had expanded globally, especially after the World War II. This led to a significant increase in carbon dioxide emissions due to a widespread burning of fossil fuels like coal, oil, and gas to power industries, vehicles, and electricity generation. Charles David Gilling, an American scientist, recognized the need to study whether the rise in carbon dioxide from human activities was affecting global temperatures. He wanted to understand the relationship between fossil fuel emissions and climate change. Keeling selected Mauna Loa Observatory, located on an extinct volcano in Hawaii, as his research site. This location was ideal because it was far from industrial pollution, ensuring accurate and uncontaminated measurements of atmospheric carbon dioxide levels. Keeling began continuous measurements of atmospheric carbon dioxide in 1950s. He plotted his findings on what is now known as the Keeling curve, a graph that shows the steady rise in carbon dioxide levels over time. This data provided the first clear evidence on how human activities were increasing carbon dioxide concentrations in the atmosphere. The Keeling curve became a landmark in climate science, demonstrating the link between industrial emissions and rising greenhouse gas levels. It also underscored the urgency of addressing human contributions to climate change. But how can scientists account for the correlation between the amount of carbon dioxide and the temperature? Is the temperature higher because carbon dioxide is higher, or are the values simply coincidence at this time in history? To answer to that, scientists use a combination of historical data, ice core samples, and modern measurements to demonstrate the correlation between carbon dioxide levels and global temperatures. Ice cores provide a record of atmospheric carbon dioxide concentrations and temperatures going back hundreds of thousands of years, showing that periods of high carbon dioxide are consistently associated with warmer climates. Additionally, experiments and models confirm that carbon dioxide traps heat by absorbing infrared radiation, a process known as the greenhouse effect. Is the temperature higher because carbon dioxide is higher, or it is just a coincidence? It is not a coincidence. Decades of research have established that carbon dioxide acts as a greenhouse gas, trapping the heat in the atmosphere and directly influencing global temperatures, while other factors like solar radiation and volcanic activity can also affect climate. The rapid rise in carbon dioxide due to human activities correlates strongly with the observed increase in global temperatures since the Industrial Revolution. Does correlation prove causation? While correlation alone does not prove causation, scientists have demonstrated causation through controlled experiments, physical principles, and climate modeling. For example, laboratory studies show how carbon dioxide absorbs and emits infrared radiation, and climate models simulate how increasing carbon dioxide levels lead to temperature rise. These findings confirm that rising carbon dioxide levels are a primary driver of current global warming. Question: why does the average temperature of the atmosphere rise? What might have caused the unprecedented increase in its level? Well, the average temperature of the atmosphere rises due to the greenhouse effect, a natural process where greenhouse gases such as carbon dioxide, methane, nitrous oxide, water vapor, and ozone trap heat in the atmosphere. These gases absorb infrared radiation emitted by the Earth's surface and re-radiate it, warming the planet. However, human activities have significantly intensified this process, leading to an unprecedented rise in temperature levels. The primary causes include the burning of fossil fuels such as coal, oil, and natural gas, which release large amounts of carbon dioxide. According to the Intergovernmental Panel on Climate Change of 2021, fossil fuel combustion is the leading source of carbon dioxide emissions. Additionally, deforestation reduces the number of trees that absorb carbon dioxide, leaving more of this gas in the atmosphere. The Food and Agriculture Organization of 2020 highlights that deforestation has significantly diminished global carbon sinks. Moreover, agricultural practices, particularly livestock farming and rice cultivation, emit methane, a more potent greenhouse gas than carbon dioxide. Industrial processes also contribute to greenhouse gas emissions, further amplifying the warming effect.
These human-included factors have intensified the greenhouse effect, causing the sharp increase in global temperatures observed today.